hello, welcome to the show. It's me, JP, and it is time for JP's product pick of the week. And this is, in fact, the final JP's product pick of the week for this year, 2023. I'll be off the next few days for the holiday break, so I will see you again in the new year, or maybe on Show and Tell on Wednesday. So thank you all for coming to the show and coming to the show all throughout the year. It's been a lot of fun to put these together and to be able to offer you some discounts on some cool Adafruit stuff. So thank you, and thanks for joining us in the chat. We've got some people over in our YouTube chat. Hey, Dave Odessa. Hey, Tackle the World. Nice to see you. Of course, we have our Discord chat, and that's a good place to check out if you're somewhere else and you're wondering, where's the chat at? That right there, that's our Discord chat. That's at adafru.it/Discord, and then you can jump into the live broadcast chat channel and hang out with the likes of C. Grover and Starman and CTG Controls and Toddbot and Jim Hendrickson and Thin Man and Yanisku7. Hello and welcome to the show. Thanks for stopping by. So we've got some squiddy stuff here today. I don't know how squiddy it is, but it's sort of squiddy, sort of octopusy-ish. So before I go too much further, what I'll tell you is you can head to that QR code or that URL right there, and you will find your way to the product page, excuse me, for this week's product pick. Jump on over there. Do I have that number right? I kept writing that number wrong. 5836. Yes, that's it. That is the product ID for this week's product pick. Head on over there because you will find that we have a big, huge discount. Cut the product's price in half for you, a maximum of 10 per customer. Jump on over there and you can check out this week's product pick and still watch this very live video because it's streaming right there inside the product page. Now, before I tell you any more, let's have Lady Ada jump back a little bit in time and tell you about this one. Take it away, Lady Ada.
Okay, so we've got the BNO055. It's actually one of our popular breakouts.
That's not it at all. I didn't swap the thing out. Okay, hold on one second. Let me. Wow, 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 wow.
Okay, so we've got the BNO055. It's actually one of our popular breakouts. This is a sensor that has a 9-DUF accelerometer, gyroscope, magnetometer in it, and it will also give you quaternion and Euler values output. And why is that handy? Well, you can use a microcontroller that's fairly high power, like Cortex M0 or M4, to...
Okay, here we go. I meant this time is what I meant, is Lady Ada talking about this week's product pick. Sorry about the snafu.
Oh, the ADS7830. This is a fun little ADC. We've had people ask, hey, you know, I want to add a lot of analog inputs to a chip or microcontroller or Raspberry Pi. And I like the ADS1015 series, but they're a little pricey, and they're a little pricey. This is much less expensive. It's about half the price, and it has twice as many channels. It's not as precise. It's an 8-bit, not a 10 or 12 or 16-bit ADC. So it's not for like precision measurements of like a thermistor or like a microphone or whatever, something where you need 10, 12 or more bits of accuracy, precision. What it is good for is potentiometers or a flex sensor. You know, if you're cool with only having 0.5% precision, then 8 bits is plenty. And I think for a lot of purposes it is, especially since it's going to be, again, lower cost and you get 8 full channels. So we put this on a breakout board. You can use it with I2C. We've got Arduino library, CircuitPython, and Python coming shortly. You can change the address. You can have up to 4 of these on one single I2C bus for 32 total channels. It runs from 2.5, 3 volts to 5 volt logic and power. You can, by default, uses the power as the reference. If not, you can, of course, have an external reference. It just be smaller than the power, I think, but I'm actually not sure. Check the datasheet for that. But not a lot going on this breakout board. So check the datasheet for the ADS7830. It can do up to 70 kilosamples per second over I2C, and we just kind of rigged it up so that you can quickly get it going on your microcontroller that needs more analog inputs.
All right.
That's right indeed. So look, here it is. This right here, that's the product pick of the week this week. Whoa, it is the ADS7830. Let me say that again. It is the ADS7830 8-channel 8-bit ADC. It's an analog to digital converter. It runs over I2C using the Stemma QT port. So this is great for hooking up to either a board like a Raspberry Pi that just doesn't have any analog inputs, but it does have I2C, or if you want to really easily add 8 analog ins to pretty much any microcontroller project. It is 8 bits, so it's terrific for things like MIDI, which is actually 7-bit message, so you can get pretty accurate MIDI using some knobs or sliders or faders. And I should say, what is it? Well, it's an analog to digital converter. That means you can take analog inputs such as knobs and slide potentiometers and force sense resistors, and you can read those analog values. It will turn those into 8-bit digital values, 0 to 255, send those messages over I2C to your microcontroller, really easily integrated with Arduino and CircuitPython. So I will, first of all, jump over to the site right there. You can see here it is. It is $2.98 today per board. Super great bargain, half price. You can get a bunch of these, right? You can string together up to 4 of them. So if you have 32 inputs. Let's say you have a 32 knob or 32 fader box that you want to build. This is a pretty nice way to do it. It is plug and play. You can integrate it into your breadboard projects, into PermaProto. You can just simply plug in Stemma QT ports, or you can even build them into PCBs, such as the FaderWave project I built, and I'll show you an example using that in a little bit. And what else is there to say? So you've got 8 bits, 8 per channel, and 8 channels to read. It is a reference voltage that's coming over the Stemma QT port normally, or through the voltage in port. However, if you have a specific reason to use a different voltage level, you can cut the trace for the reference voltage jumper and then plug in your own stable reference if you're really concerned about noise in particular. And what else? Yeah, we've also got jumpers on the back for changing the I2C addresses, so you can have up to 4 addresses of these, so up to 4 of these boards on a single microcontroller's Stemma QT or I2C port. Here is a nice little photo of all that as I talk about it. So you can see there we have external reference, we have the jumper pins, we have Stemma QT ports on the side, so you can run a daisy chain of these if you want. And you can see we also have the pins broken out, so you can solder pins onto there to press it down into your breadboard or into your PermaProto project. Let's see, what else? Let's take a look at this running in practice. So I'm going to just reposition that one there and refocus a little bit, or a lot bit. So here you can see I've got my FaderWave PCB that I built. This was something I built specifically for using 16 faders. And I have a little microcontroller over here, the Itsy Bitsy. And I have 2 of these great little 8-bit ADCs so that I can gang them up. Each of them is reading 8 of the faders, and then those messages are traveling to my microcontroller over I2C. I just have it routed in the PCB form rather than through some cables like Stemma QT cables. You can see in this example, I'm just showing a typical sort of mixer board interface in software. And so as I move these faders in this application, this is some different software that I wrote, some different code for the FaderWave to send out MIDI signals rather than the one that I had been showing before, which was generating different waveforms for SynthIO. So this is just purely a MIDI fader board, and then I'm reading in USB MIDI messages in software to control this little mixing board that you can see here. This is, if you're curious, a VCV rack, which is free open source modular synth software, and I'm using the MindMeld 16-channel mixer here. So you can see that resolution I'm in fact sending is 7-bit. Although we're reading 8 bits per channel, I actually only need 7 bits, so 0 to 127. And that gives me a pretty stable signal. Not a lot of jitter in that, sometimes a little bit just because of the mechanics of the faders. But you can see here we've got some pretty stable smooth, it's very responsive type of reading on those analog inputs. If you look up here at the code, you can see it is actually pretty straightforward to read these. So let's take a look here. The things that matter in this code, I am importing Adafruit ADS7830 as ADC, and I'm importing ADS7830 analog in as analog, to import the analog in from that library. Then I am setting up, I've got my I2C bus, and I'm setting this up with a frequency of 400, what is that, 4,000 hertz? 400 hertz? 400,000 somethings? Whatever that number is. It's less than a megahertz, about half a megahertz. Then I'm initializing 2 of these ADS7830s on my I2C bus that I set up, one of them at the default address of 48. The other, I happen to weirdly solder jumper A1, so this is showing up as address 4A rather than if I had soldered the sort of proper first jumper, which is the A0 jumper on the back. That would give me address 49. But it's okay. You can just tell software which ones you're using. So these are my 2 boards that are on the STEMMA QT or I2C channel rather. And then I set up a little list of faders based on instantiating the 2 sets of those on the analog input of the ADC board. And then in the main loop of the code, really the easy part here is now that I have that list, I can just iterate through them and ask for their values. So basically saying, hey, ADS.value, what are you? That dot value just returns, it's actually a 16-bit that you get back just because of the way the values are processed internally in CircuitPython. But then I'm actually cutting it down to a 7-bit value by doing this divide, integer divide of 512. So that gives me the 0 to 127 range, which is what MIDI CC is. If we wanted to use this for 8-bit stuff, you could divide differently, but you're not going to go higher than that. So that's the basics of setting that up. It's pretty straightforward. If you look back at the main Learn Guide page here, this primary guide, you can, let me open up this other one in another tab for a second. You can see here we've got a nice guide here by Liz Clark, takes you all through the intricacies of it, the pinouts, the little solder jumpers on there, how to use those, setting up your I2C. You've got the inputs for the 8 different analog inputs there, a little bit of I2C bus address math for you. There's a little bit there on using the external reference. And then we have both a CircuitPython and an Arduino section that'll take you through some examples of how to use these in either of those environments with your microcontroller. And this is the Learn Guide I just did that uses 2 of these in it, 2 of these nice little boards in it. This is the Fader Wave synthesizer. Learn Guide just went live. I haven't even blogged it yet, but thanks to Lamore for checking this out and publishing it. Let me go to the preview. Is that the preview? Yeah, that's the preview version of it. You can see here, I've got some demos of this being used as a synthesizer waveform generator. Here is the circuit, so you can see there are my 2 little ADS7830s being used to connect up to those slide pots. These could be regular potentiometers, these could be soft pots, kind of any of your typical analog inputs. And then I've got now a nice little section on assembling the synth, including prepping these little, don't forget this part, prepping these so that they have different I2C addresses before you plunk them into your PCB. Or if you're using a permaproto, just make sure you set those addresses, because otherwise they're hidden under there forever and you might be doing some desoldering. I just lived with it and did it in code because I had set the wrong address. And then we've got some videos of this in action, a little software explainer. There's some little fader shape, waveform shapes being done with the faders. So look at that. There it is. Very nice and responsive. Gives you 16, with 2 of these, it gives us 16 different faders we can read with 8-bit resolution. What else? Anything I'm forgetting here? Check my notes. By the way, I believe with the reference voltage, if you go back to this view here, if you cut the external reference, or I guess, do you solder it? I think there's a line there. I think you cut it. Can I see it? Might be very small. Yeah, I think you'll cut that. I think there's a trace there to cut. If you switch it to the external reference, whichever way that is, we should check the Learn Guide. I believe there's an I2C command you can do in the constructor of setting up the object in code to say you want to use a built-in onboard 2.5 volt reference, which is taking the incoming, in this case 3.3 volts over the I2C, and it's using a little internal voltage regulation, drop that down to 5.2. Or you can, and probably the way you'd be more likely to do it if you were doing this at all, would be to set up your own little separate reference voltage that you have that's a nice, clean, separate voltage that you're going to use as reference, and then you would plug that into the ref pin that's on there. Let's check, actually. Yeah, I said I would check. Let's check. Does it... I need a nice big picture of it. Pin out. Cut the jumper. Yeah, so there's a tiny little trace there that I just can't see without some more magnification. But yeah, you'll cut that trace, and then you won't be using the 3.3 volts. You'll be able to use I2C command to use 2.5 or just whatever external you plug in there. By default, that is just tied to the V in. Let's see, any questions? Question about the sample rate. Seagrover says depends on the sample rate. Oh wait, what was the original question? As a B2C SF 8-channel ADC could be used for a human brain interface. I assume that's with like the little brainwave measurement. I don't think so. I think that's a more specific amplification type of circuit, more like on our load cells. I could be wrong, but I don't think this would be what you would use for those types of sensors. I don't know a lot about those, but I think they have very specific amplification and sensing. Seagrover says looks like a non-buffered sample and hold circuit. Todd says, how does one model the impedance of an unbuffered input going straight into a capacitor? In the steady state, I guess that's leakage current. Okay, there's a heavy conversation. I should bring it up. A heavy conversation going on in Discord that's flown way over my head. Easy question, Dave Odessa. Have you been on the Christmas cheer? So far, my Christmas cheer is this fake piece of holly and pine bough or cranberries. I don't know what that is. And of course, Lars. Lars is always festive. Should have gotten him his Santa hat. I don't know where that went. Okay. I think that's going to cover it then. So let me know if you don't have any other questions in the chat. Go on over to that URL, 5836, and you can grab yourself, see if we've still got them in stock here. Grab yourself some of these. I know we had about 100. Yeah, we got plenty. It didn't drop to where it's telling us the limited numbers. So you can go grab some, throw a few in your cart if you're thinking of doing some sort of reasonable resolution. These are 8-bit. So 8-bit, it's great for things like MIDI, other types of maybe robotics controls, some game controller types of applications. We have other ones that'll give you a higher resolution but fewer inputs. So it kind of depends on what your goals are. That is it. So grab that off of there. That is my product pick of the week this week. It is the ADS7830 8-channel 8-bit ADC with STEMMA QT I2C for giving you lots of analog inputs in your microcontroller projects. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week, and I will see you either on Show and Tell or in the new year. So thanks everyone for stopping by. Take care.